Right. Share my screen. Okay, so I think I have it now. All right, so plan is to do the question down here while we have that other window open at the top. We can do it vice versa. All right. So we're starting with this first question, question 1a. So it gives us that fraction, and we have to use a calculator or otherwise to find the exact value. So I mean, we can put it in decimal and round off or anything like that. Give the exact value. So usually we'll give it back as a fraction. We want to give the exact value. All right, so you always want to write the numerator first, the entire numerator before you divide. But this one kind of friendly because of the multiply here. All right, so it's a matter of typing that in the calculator exactly as it is, and you will get the correct answer. So it's good if you can practice that. But let's go step by step. If we're going step by step, then we want to get rid of those improper fractions. So this improper fraction here will become 3 times 2 is 6 plus 1 is 7 over 2. Multiply that by this fraction now would be 3 times 1 is 3 plus 2 makes 5 over 3. And you're dividing that by this fraction under here now is 4 times 5 is 20, 21 over 5. All right, that's what we get first up. And then now we can proceed by multiplying this out. And so it will become, we're multiplying this on the numerator now. And so it becomes 7 5 is 35. Over 2 3 6. And then when you divide by a fraction, you invert and multiply. So we're going to invert and multiply by that fraction. All right, so we're going to be multiplying that now by 5 over 21. All right, and there's no matter of simplifying the expression. So, so basically, hold on there. All right. All right, so hold on. All right, so this now becomes, if you use a calculator, it becomes 1 and 7 over 18. 1 and 7 over 18. That's what we get when we simplify it. All right. So basically that's it. All right. So what do we go with that? Use the calculator and simplify that.
Yes, sir.
All right, good. And we'll move up to this part. Which basically, again, is just use a calculator to work this out. And again, what it is that we have to do this part first before we subtract. All right, and so first it will become 5.47 minus, and we'll do this calculation. It works out to square root of 0.0676 initially, and then it becomes 5.47 minus 0.26. Work that out, and then it then becomes 5.21. 5.21. All right. Oh, by the way, for this one up here, we could have simplified this divide this by 7 and get 3, and divide this by 7 and get 5, and then it will be 5 5s 25 over 6 3s 18, and that is when we now come down from here to this. So to simplify to a simpler improper fraction first. Anyway, the answer for this one now is 5.21. All right, so moving along. So the second question now, let's move this up as well, is this thing. All right. That's very rich. All right, so this question now gives us this table, and it says the table below shows the number of tickets sold for a bus tour. Some items in the table are missing. All right, so there's no value here. There's no value here. Where is it? Right. There's no value here. Let's go again. There's no value here. Oh Lord. Here. We don't know this value. We don't know this value. We don't know this value. All right. Mute the mic, please. But what happens is that these are the number of tickets here. This column. This column is showing the cost, and over here is showing the total. And the relationship is that we multiply the number of tickets by the cost to get the total. All right, and then we can get in the relationship between those. So first thing I want us to find is P. So it is clear that 5 times P is equal to that figure. All right, mute your mic, please. Mute your mic, please. All right, so it means that 5P is equal to 130.50. And so you have to divide by 5 to get P. So the P is equal to 130.50 divided by 5 equals, let me see what I can do with it. Just give me a second.
This is an extraordinary. All right, here I go.
Right. And so we'll do this calculation now. 130.5 and divide that by 5. And so we get 21.
26.10.
26.10, yeah. You have to put the 0.10 because it's the money figure you're putting inside here. So you have to put that. All right. So that's that. So move down to the next part. They now want us to find the value of Q. So again, it is this figure times this figure equals that figure. All right. So therefore, the Q is equal to 14 times 44.35. And so the Q is equal to, can you tell me?
620.90.
620.90. You have to put the 90 because remember it's money, right? So you have to put the 90. Calculate, that will give you a 0.9. You have to put the 0. Remember it is money. All right, so that is that one. All right, and we're moving up again. So we just worked out. Let's write it up here. This section. We worked out up here that the P is 26.10 and the Q is 620.90. All right, so that's what we know so far. All right, so back down here. Oh Lord, okay. So I'm moving up to the next part. So we're back up to here now. So the question now says an adult ticket. So these are the adult tickets up here. An adult ticket is actually now twice the cost of the youth tickets, and these are the youth tickets. And this is the cost of the U tickets. All right. And adult ticket is twice. So it means that right here will become 2 times this figure. So 2 times the 44.35 becomes 88.70. So the adult tickets is for that. So and the one does know to calculate the value of R. All right. So the R. So again, it will be let's leave that. It will be R times the 88.70. That will now be equal to the 2483.60. Understand that? Work out the adult tickets. For the tickets, adult ticket cost is 2 times 44.35. All right, which basically gives us the 88.70. And so to find the R, we're going to divide. So the R then is 2483.60 divided by 88.70. That gives us the value of R. So 2483.6 divided by 88.7. 28. So that's 28 tickets. So there were 28 adult tickets. So if we come back up here now, this is 28. 28. All right. All right. So that is that part. So coming right along now, it says the bus company pays tax of 15% on each ticket sold. Calculate the tax paid by the bus company. So basically, if you pay 15% on each ticket, then the overall is also going to be 15% of the total. All right. So the tax then will be 15% of the total tax. Total tax will be 15% of total cost of all the tickets. And so that is 15 over 100 times the total tickets now. You have to add up the cost of all the tickets now. So it's 130.50 plus 620.90 plus 2483.60. All right, that's what you're working out. And that becomes 15 over 100. And the total there now, in terms of dollars, is in dollars and it's 3235.00. And you work out the 15% of that. Tax paid is 485.20. 485.25.2.
25 cents, sir.
Yes, 25 cents, right? All right, so basically that is question 1. All right, so moving down now to question 2. All right, so question 2 now. Question 2 now gives us this fraction. Question 2 gives us this fraction, right? Now, when you're adding fractions, essentially you want the 2 denominators to become the same, right? You want the 2 denominators to be the same. Right now, they're not the same. So you want to adjust 2 fractions to make the 2 denominators the same, right? So what you can do is multiply this denominator up here and down here, and at the same time multiply this denominator up here and down there. And what will happen is that the two denominators will become the same. So we're going to multiply this fraction by 3 over 3. I'm going to multiply this fraction by 4 over 4. As like I'm multiplying each fraction by 1. And that is just to get the two denominators to be the same. And so this becomes equal to 4 2 is 8, so that's 8x. 4 3 is 12 over 4 3 is 12. Let's write that properly. Plus 12 divided by 4 3 is 12 on the denominator. Plus, you're multiplying by the 3 now. So 3 times x is 3x. 3 times negative 4 is negative 12 over 3 times 4 is 12. So now that the two denominators are the same, it means that we can just add the numerator values. Alright? Add the numerator values and put by the common denominator. And so basically the 8x and the 3x is 11x. This becomes 12 and negative 12 and negative 12. That's what happens. 12 and negative 12. So 12 and negative 12 is 0, and you're dividing that by the common denominator of 12. But understand that? Very good?
Yes, sir.
All right, good. So moving on now. So moving on to the next part. Part B says we are to write the following statement as an algebraic expression. All right. It says the sum of a number and its multiplicative inverse. The multiplicative inverse of a number n is 1 over n. And multiplicative inverses are such that when you multiply them, the answer is 1. For example, the multiplicative inverse of 2 is half. So these are two multiplicative inverses of each other. The multiplicative inverse of 2/3 is 3 over 2, because if you multiply them, you're going to get 1. So multiplicative inverse of a number is basically the reciprocal of the number. Now, 0 has no multiplicative inverse, because if you try put 1 over 0 as a multiplicative inverse, 1 over 0 is undefined, is equal to infinity, meaning it is undefined. All right, so 0 is the only number, the only real number that has no multiplicative inverse. 0 is the only real number that has no multiplicative inverse. All right, so by understand that 0 is the only number that has no multiplicative inverse. So let us erase this now. All right, so back to this now. So let's call the number n. So the number is n. Then the equation is that the sum of a number and its reciprocal inverse. That's n.
And 1.
It said the sum, so it's plus the sum of a number and its inverse is means equal 5 times the same number. 5 times the same number. So that becomes the equation. The sum of the multiplicative inverse of the sum of a number and its inverse is equal to 5 times the same number. But understand that? But I go do that?
Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
All right, cool. All right, so moving on now. So the next part is for us to factorize this thing. So we see 2 terms there. That is clearly the difference of 2 squared, because the 36 is a perfect square. All right. So this can be written as x squared minus 6 squared. And when we apply the rule of the difference of two squares, it becomes x minus the 6 times x plus the 6. Basically, that's how differentiate or factorize the difference of two squares. The difference of the two values times the sum of the two values. Difference of two squares. All right, so then we'll come down to this one now to factorize. That clearly is a quadratic. Remember, when we're factorizing a quadratic, the aim really is to split this middle term and convert it from 3 terms to 4 terms so that it can then factorize by parts. All right, so the procedure is the first multiple. We're trying to find we're going to use this operation to split the middle term. All right, and what's that operation? You multiply the two n coefficients first. So multiply the 2 times negative 12. And 2 times negative 12 is equal to negative 24. Negative 24. In search of factors of negative 24, that give you the middle term of plus 5. That's what you want. So if you can't see what those two factors are right away, then you can go down the list of factors and search for it. So let's assume that you didn't see what it is. So you want to search for them here. So since you want the factors of a negative number, then one of the factors will be positive and one will be negative. You have to get the larger of the two factors of negative 24, the sign of this thing up here that you want, which is positive. So the larger of the two factors of negative 24 will be positive, and the smaller one will be negative. All right, so let's try and factor. Let's say we don't see what it is, our trying factors. First factors of 24 is 1 and 24. Give the larger one the positive sign and the smaller one the negative sign. And then we do 24 minus 1, we get 23. We don't want 23. All right, so go to the next two factors of 24, which is 2 and 12. Give the larger one the positive sign and the smaller one the negative sign. But then negative 12, negative 2 and 12 is 10. You don't want 10, it's 5 you want. So then you go to the next 3 and 8. Give the larger one the positive sign and the smaller one the negative sign. And then the negative 3 plus the 5. The negative 3 plus the 8 is 5. I can say 8 minus 3 is 5. And so yes, you have found it. So you're going to split this 5x into negative 3x plus 8x, or you can put 8x minus 3x, any order. All right? So then we're going to split this now. So basically this becomes 2x squared. I'm going to put the plus first, plus 8x minus 3x minus 12. Let me put a line down here to separate this thing. That was just to find what we're going to split it into. And when you do that, you must always check the values here to ensure that it gives you back the middle term. Right? Just in case you make a mistake, you always check. So 8x minus 3x is plus 5x, and you have to pay attention also to the sign. So it's really plus 5x you want, not just the 5x. So 8 plus 8x minus 3x to give you a plus 5x, so you know, so that is fine. Always do that check. All right, and then now you're going to factorize by parts. First two terms first. All right, so the highest common factor you're going for now. The highest common factor the first two terms is 2x. 2x divided out of 2x leave 2x squared. 2x divided out of 2x squared gives me x. And 2x divided out of 8x gives me 4. So it's x plus 4. And the safe thing to do is to put back the x plus 4 in the bracket over here, because the two brackets must have the same thing. And you look from a negative 3x and you factor the x inside here, you must have factored out the negative 3. Right? And you always factor out a negative something or a positive something. So you're factoring out a negative 3, not just 3. You cannot just say you factor out a 3. No, you factor out a negative 3. Very important. All right, and you do your check. Negative 3 times x right here, give me this, and negative 3 times positive 4, give me negative 12. So you do that check, and you know that it is correct. And you get what, if you expand back what you have there, you will get what you had at the top. So you know factorize good. Then the x plus 4 is a common factor. And so it becomes 2x minus 3 times your common factor. All right, so it factorizes into 2x minus 3 times the common factor of x plus 4. And as I said, if you did it another way by switching the values, and you got x plus 4 times 2x minus 3 instead, that is still correct. In one of those you get is correct. All right, so it's that or that. In one of those you get, it's still the correct. Those are still the two factors in any order. All right, so basically that is that. All right, so let's see where we reach up here. That's going on to the next page. All right, so let's go. So next part here. All right, so this says the formula for the volume of a cylinder is given as V equals pi r squared h. You know that the r is the radius and the h is the height. They want us to make make r the subject. Want to make r the subject. So starting with V equals pi r squared h. So we want to leave r as a subject. So we're going to divide both sides by the pi and the h to leave the r squared alone first. We'll divide both sides by that. All right, and that's how we get rid of the pi and the h. So basically then it becomes V over pi h equals r squared. And then now, from that, we want to get rid of the square. So to get rid of the square, we do the inverse of square, which is to square root. So we square root both sides. And so we square root both sides. The r is equal to the square root of everything. Everything must be under the square root sign. So it's V over pi h. Everything is under the square root sign. Now, normally I would say put plus or minus when you calculate square root. But because we know that we're talking about volume, these dimensions cannot be negative, because you can have negative volume. So the r must be a positive and the h must be a positive. So in this case, I would leave it without putting the negative. So we can write the final thing down. Because the subject, we're going to put it with the r on the left side. So when something is a subject, it is on the left side. So we're going to write our answer as r. So we can say, therefore, r equals the square root of v over pi times h. And basically, that's it. All right. So far, so good. All right. So that's that. So moving right along. All right. So moving up to here now. I want us to do this thing now. All right. So they want us to find the value of a and b. So given that this expression is equal to that. In other words, what you see is that they have completed the square to get that. But it's normally when they tell you to complete the square, they give you these values and ask you to find these values. But they're doing the other way around now. So no problem. All you have to do is carry out the procedure, or you can expand the right side. I think the easiest way is to expand the right side and get it back out in the standard form. Remember, this is a standard form, and this is called a vertex or the turning point form. And you can go from one or the other. So we'll complete the square to go from here to here. But to go back from this one to this one, all we have to do is expand. All right. So we're gonna just expand the right side and then compare the values. All right. So all we have to do. So I think it's relatively easy. All right, so we're gonna keep this side as it is. So it becomes x squared plus ax plus b equals. We're gonna expand the perfect square now. So remember, we expand this perfect square right here. You have to remember that there's a middle term. It is not x squared plus 2 squared, which is 4. That is wrong. All right. And when you expand a perfect square, you must get 3 terms. All right. So let's remind ourselves of that. Oh Lord. All right, I have to write this over. All right, let's be equals all right. So what you're gonna get is x squared. Then the middle term is twice the product of a 2. How you do twice the product of a 2? You multiply the two values in there, and you double the result. So you multiply the x and the plus 2. So x times plus 2 is plus 2x, and you double that to 4x. You double that to 4x. So the middle term is 4x. And then they square the 2, you get 4. You get 2 squared now, which is 4. And then you're subtracting the 3 minus 3. So all this part right here is expansion of the perfect square. All right. And then now you want to consolidate the values on this side. So this comes back now to x squared plus 4x. And then the 4 minus 3 is 1. 4 minus 3 is plus 1. And then you compare the values. You compare the values here now. It means that the x squared plus ax plus b is equal to that again. So therefore, the a equals 4 and the b equals 1. All right, let's remind ourselves of the perfect square expansion. So if you're expanding a perfect square, let's say p plus q all squared. This expands out into the first term squared, which is p squared, plus twice the product of a 2. Twice the product of a 2 means that you multiply them first and you get pq, and then you double it. So that's why you get twice the product of a 2. And then you add the second term squared. Second term squared. If this instead was p minus q all squared, then the first term squared is still p squared. The second term would have a minus because it would be p times minus q is minus pq, and then you double that, so it becomes minus 2pq. And then the last term is still plus q squared because negative q squared, the negative q squared is still positive q squared. And this is just a reminder of how you expand a perfect square. Plenty of people make the mistake all the time or do something like this. So for example, they have x plus 3 squared. Common mistake is for them to just do x squared plus 9, which is wrong. Alright, so I don't want anybody doing that. You have to remember. Alright, I'll show you the long way in terms of the perfect square. Let me just put it up the top and show you. We're looking at the long way. Let's look at the perfect square expansion up here. Let's show you. So if we're doing, up here now. Let's say we're doing a plus b squared. A plus b squared is really a plus b times a plus b. If you look at it. And then how you carry out this multiplication is multiply the a times the a. So one can get a different color for that. Let's use a different color for that. Let's use the orange. All right, so you do the a times, I change everything. All right, so I do the a times the a, and then the a times the b, and then the b times the a, and then the b times the b. All right, so when you do that, you get a times the a is a squared. A times the b up the top is ab. And then come under here now with the b times the a. So you get b times the a is ba, but ba is the same as ab. And then b times b is b squared. So you see, you have twice the product of them in here. Twice the product of a 2. So that's why twice the product of a 2 comes in. All right. So basically, that is how we get it to be the first term squared plus twice the product of the 2 plus the second term squared. So let's try not to make a mistake. When students did this question in this exam, a common mistake was for them to just write it as x squared plus 4. All right, so let's not do that, please. You have to remember these basic things. All right, so that is that. So moving on up to the next question now. All right, so next question is a set. I mean, set is no longer on paper 2, but it's on a multiple choice, so we can still do it. All right, which is this one. All right. So this question says the incomplete Venn diagram shows the number of students in a class of 28. So I'm going to put that information on right away. So since the class of 28, I'm putting 28 right here. So that reminds me that everything must add up with 28. Right? I'm putting 28 right here. Everything in the universal set add up to 28. It says, and they play football and tennis. So clearly the F is football, the T is tennis. It says, you are all the students. And for the students who play football, here are the students who play tennis. It says, additional information about the class, right, is that 12 students play tennis. So 12 students play tennis, means that everything in the tennis set must add up to 12. So I'm putting that 12 right here. It says, 15 students play football. So everything in the football set must add up to 15. So I'm putting a 15 right here. And it says 8 students play neither. So 8 students are out here playing neither. So I'm putting an 8 out here. 8 students are outside of the football and everything. So I put 8 anywhere in this region. I don't. All right, so put 8 outside for the 8 students who don't play any of those. And then now X play both, and that's what this X is for. Excuse me. So X students play both. So because the total in the tennis is 12, and you have X inside there already, this region for the tennis only is therefore 12 minus X, because the total must be 12. And similarly, since the total in this set is 15, and you already have X inside here, it means that the section here for football only must be 15 minus X. Excuse me, not corona. All right, so that's the completed Venn diagram right there. All right, so that's it. And the next part now wants us to calculate the value of X. So to calculate the value of X, we're going to use the information that the total in the Venn diagram is 28. So all the values in the Venn diagram must add up to 28. All right, and how we can do it, we can start by saying this set is already just 15. All of this set is 15. So I'm going to use that as one set. So total, I'm going to use the fact that the total is 28. Total in the Venn diagram is 28. And as I said, this set right here, set F already is 15. So I'm going to say 15 plus 12 minus X plus the 8 outside must equal 28. And you're solving this for X. All right. So the 15 and the 12 is 27 minus X. We can carry this 8 over here and subtract it. And so it becomes 20. And then now, to get the X, we can carry over the negative X and carry over the 20. Or simply put, 27 minus 7 equals 20. So anyway you want to look at it, the X is equal to 7. X is 7 because 27 minus 7 is 20. So that's the value of X. All right, anyway you want to look at it, that is it. All right, so that completes that question. All right, so far so good. All right, let's move up again. So next we come to this construction question, and it's difficult to do the construction. But let me see if we can talk it through it still. All right. It's difficult to do the construction. I'll show you exactly what it's happening without the instruments, but let's go. It says use a ruler, a pencil, and a pair of compass, meaning those in a protractor. Construct trapezium A, B, C, D If AB equals 8, the angle at A is 60, AD equals 6, and the angle at B is 90. And it says AB is parallel to CD. So what I always encourage the students to do is to sketch it first, and you sketch what you're going to construct so you can see exactly what you're constructing. All right, so I'm going to put my AB and the ABC must go around the object in one direction. Either go ABC either going around the object in this direction, or it going in that direction. Your choice, it don't really matter. Right, but you must be consistent with the direction. Either you're going clockwise around the object or anti-clockwise. So if I put AB here for my sketch, AB, all right, then AB is 8. Then it means that C is up here and D is over here. All right, so that's the first thing you want to establish. All right, so let me write them a little bit higher. C is somewhere over here and D is over this side over here. All right, I'm just sketching. All right, so the angle at B is 90. So angle ABC is 90. So the angle at B is 90. So I'm going to need a 90-degree angle up here. That will take me up to C. All right. So that will take me up to C. So this angle here is the 90-degree angle. And then the angle at the A, angle at the A, angle BAD, angle at the A is 60. So I have to construct a 60-degree angle here. And that will take me up to, and they give me another distance. So they tell me a distance. They tell me that AD is 6. So I'm going to make this 6. It's 6 centimeters. That is 8 centimeters. And then they said that AD is parallel to AB. Right? No, AB is parallel to CD. So it means that these two lines parallel. All right, so this angle here is 90 as well. Basically, that's what you're constructing. That's what you're constructing. All right. So let me see if we can talk through the construction. Let's talk through it to see if you construct this properly. All right, the first thing I'm gonna do is use a ruler and draw the AB. So use a ruler, measure 8 centimeters, and you draw it. All right. So draw that line across for 8 centimeters. Let's see. So you draw your 8 centimeter line first. Let's undo that. And then mark off the 8 centimeters on the line. All right, mark off the 8 centimeters on the line. So mark one end and you mark where 8 centimeters, one small mark. So that is a AB. And then now you want to construct the 60-degree angle over A. You want to construct a 90 degrees over B. All right. So to construct a 60-degree angle, you really need 2 arcs. Starting at the point A, you draw both the compass a reasonable length and you tighten it. So you can change the angle after you set the compass. So you put the point at A and you make an arc in this direction, like that. All right, something looking like that. And then now you put the point of the compass back here. And with the angle of the compass the same, you make an arc this way. You can arc around here to cross this one. And then what happens is that the straight line up here now through there will be 60 degrees. Straight line through A and the intersection. Make this angle 60 degrees. All right. And then all you have to do now with the ruler is measure at 6 centimeters. You're going to measure this now with the ruler. 6 centimeters, right? So you measure this 6 centimeters with the ruler. Question says you can use a ruler. So I'm going to extend this line out to 6 centimeters. So 6 centimeters is around there. All right. So that there for, oh Lord, undo. Redo. All right. So let's get about the 6 centimeters. So this is about 6 centimeters out in here. And then you mark it. You mark it. And basically that's where your D is. A, B, C, D. Then over here now, you want the 90 degrees. There are multiple ways to construct the 90, but I'm going to use a simple method for now. We'll reach in the class, I'll show you another way. So the way I'm going to use is to extend this line. And it's like I'm going to bisect a 180 degree to get the 90 degree at the point A. So the first thing you do, you open your compass and you make an arc across this line all the way over here, like that. Put a point here and then you make that arc. All right, so it's almost like you're bisecting the line segment between these 2 points now. You're bisecting this line between these 2 points that I'm marking with the dots. So you open the compass more than half the length of this line, right? Maybe about here. Open the compass from this point to maybe about here. So open your compass about this length. All right, that's what you have to do. Right? Open the compass about, and then from this point, you make an arc at the top here. And then from the point on the right, you make an arc to cross that one. And when you draw the straight line through here now, it will be 90 degrees. 90 degrees. Well, you know that C is somewhere upon this line, such that this across here must be parallel to the line on the bottom. So how do we construct the parallel line? We have to make sure that it's parallel. Again, there are multiple ways to do it. Right? I don't think I have a space on this to do it. I don't have a space to do it over here. Oh Lord. All right. Oh, I don't have a space. I have to, let me go up and show you how you construct the parallel with a different. I kind of did it too close to the right, so I can't get to show you how you construct the parallel. So I'm going to use something else and show you how you construct the parallel down here. All right, and you'll have to do it on the D up here. So let me just show you down here. So let's say I have this thing. I have this thing, this line. I'm going to do it over here. So I have this line. I have this. And I want to construct a parallel line from here. A line that is parallel to this one. And I want to construct it from this point. All right. Essentially what you're doing is to do that construction is I don't want that to mess it up. Change the color a little bit. Come back here now. Right. So essentially what you're doing is you're transferring this length up to this point, right? And you're transferring this length. Let me go again. You're transferring this length up to this point. And you're transferring this length over to this point. That's where you construct the parallel line. Because basically it's like you're forming a parallelogram. It's almost like you're constructing a parallelogram. So you're trying to find a point out here. And you're trying to find a point out here. So you can get a parallelogram. So to construct a parallel line is almost like you're simulating the formation of a parallelogram. All right, so let me show you now. So as I said, to get that parallel line, what you do, you use your compass and you measure the length of this. Use a compass and measure the length of this line. Right? Now you measure the length of this line with your compass. So you put the point of the compass at this end and open the pencil point to this end and measure it with your compass. You know, use a ruler. Just use a compass and put the point here and the pencil out here. Right? And then put the compass at that length. You put the point of the compass here and you make an arc. When you make an arc, you're gonna get an arc somewhere out here from this point. So get an arc somewhere out here. And then so getting an arc somewhere out here. And after you do that now, you put the point, you use your compass and you measure this length from here to here again. So with your compass, you put the point at this end down here and put the pencil point up here. So use your compass basically to measure the length of this line. All right? And then you move the point of the compass over to here and you make an arc across this one. You make an arc from this point across this one like that. All right? So make a cross this one like that. Now, where those meet is such that, go back to the purple now. It's such that when you join here now, all right, now you're not really joining there. It's basically like you're getting a parallelogram. So the straight line through here now will be parallel to that one. Right? And basically that's what you have to do. Mute your thing, please. That's what you have to do up here to construct this parallelogram. So you have to transfer, go back for the green ink. Go back for the green ink. You basically have to transfer now this length up here and transfer this length over here. And where they meet somewhere over here, you're gonna get the straight line through there now. And that's where the construction would go. All right, so basically if you do the arc thing, you're gonna get an arc over here, like this. An arc like that. Something like that. All right. You just need to practice with your compass. And then I'll go back for the purple. You will draw a straight line through this, through the intersection. And it will be parallel to the one down there. And that will be 90 as well. Alright, and this angle down here is 90. So you can try to do the construction, I hope you understand. But we won't do this in the class. Again, we'll get an opportunity to do it in class. Right, it's kind of difficult to explain without the instruments. But basically it's something like that. Alright, you can watch over the video and see if you can just try and do what I told you. And you see the construction. Basically that will be a parallelogram. So this will be 8 centimeters and this will be 6 centimeters and this angle will be 90 degrees. All right, so that is it. All right, so let's go down to the next part. The next part now is this functions question. This part is our functions question. Let's focus on 4. All right. Okay, so this question gives us those two functions and it wants us first to find g of 0 and g of 5. So it means that we're putting the g of 0 in this and we're also putting the g of 5 in that same thing. So this becomes equal to the g of 0 is 3 times 0 plus 1 over 5 and the g of 5 is 3 times 5 plus 1 over 5. And since they have the same denominator, I kind of easy. 3 times 0 is 0 plus 1 is 1 over 5 plus 3, 5 is 15. 15 and 1 is 16 over 5. The denominators already are the same, and so it becomes 17 over 5.
Sir, it's not over 2.
It's over 2. Oh, my bad, over 2. So I'm waiting my done to tell me it's over 2. I'm start over. Over 2 Let's go back. All right, so it becomes 3 times 0 plus 1 over 2. Now, see me, my item not so good. All right, plus 3 times 5 plus 1 over 2. So it becomes 3 times 0 plus 1 is 1 over 2 plus 3 times 5 is 15 and 1 16 over 2. So the 1 and the 16 is 17 over 2. All right, so the same procedure, so I wrote on the wrong thing. That's it. All right, so let's continue. This part now wants us to find f of g of 5. Now the f of g of 5 really is the same as f of g of 5. It means you have to do the g of 5 first. So to do the g of 5, we're going to put the 5 in the g function. So the g function up here still. And the g function which is up here. All right, so this becomes f of, and the g of 5 now is 3 times 5 plus 1 over 2. Same thing that we did a while ago, same g of 5. 3 times 5 is 15, 15 and 1 is 16, 16 over 2 is 8. So this is really f of 8 now. Yeah. This inside there work out to 8. Right? And then now we just want to do the f of 5. So f of 5, f of 8, sorry. So f of 8 now means that we're putting 8 in the f function. So it becomes 4 times 8 minus 7. 4 times 8 minus 7, what is that? That works out to 25. No, no, that's 7. That's 25, right? 25. 32 minus 7 is 25, yeah. 25. This guy, that's it. All right? Okay. All right, I heard you. All right, the next part now wants f of f to the minus 1 of 1. All right, so to find f to the minus 1 of 1, let's go back on this one and show the f of x. And show the f of x, right? So to find f to the minus 1 of 1, we can find the f to the minus 1 of x first and then substitute the 1. All right? So I want to start with the function by saying, trying to find this. Trying to find that. So I want to start by saying f equals 4x minus 7. We'll just leave off the of x for the time being. We'll just leave off this of x right here for the time being. Leave off that for the time being. All right. So we'll form the inverse function now. Forming the inverse. When we form the inverse, the f, which is the range, becomes x, which is the domain. And the x up here, which is the domain, becomes the range in the inverse function. And the range in the inverse function is written with the minus 1 on it. F to the minus 1, minus 7. And we're trying to make f to the minus 1 a subject. So we're going to move this negative 7 first, and then divide by this 4. So we're going to get x plus 7, and divide under the 4. All right, so divide under the 4. And that leaves us with f to the minus 1. And that really now is really f to the minus 1 of x. So it's really f to the minus 1 of x. So this is really f to the minus 1 of x. Therefore, f to the minus 1 of 1 means that we're putting in, let me change something. Hold on. I'm putting in but of x now. So I don't want people to feel like it was a part of the original thing. So I'm going to change the color. For that, everything important. Welcome back still. Right, save. I can save it, save. Save already. Oh Lord, alright, so let's continue. This thing kind of reading I don't fully understand. So we need f to the minus 1 of 1. So therefore, f to the minus 1 of 1 means I put in 1 in this now. So it becomes 1 plus 7. Put in 1 for the x up here. So it becomes 1 plus 7 divided by 4. 1 plus 7 is 8. 8 divided by 4 is 2. So f to the minus 1 of 1 is 2. All right, moving along now up here. So this part now gives us these 2 points, P and Q, those coordinates. The endpoints of the line segment PQ. They want the gradient. Remember, gradient is difference in y over difference in x. Right? So the gradient of PQ. Let's use common letter for gradient. Gradient of PQ is difference in y over difference in x. So remember, if we're using this y value minus this y value, then we have to use this x value minus this x value. All right? Have to use the same direction, we're taking the difference. Remember, the difference in y over difference in x. So let's write out the formula. We're going to use yq minus yp. And so we have to use xq minus xp. Since we got q minus p up here, we have to go q minus p down here. All right, you can't switch it around, otherwise you're going to get a wrong answer. So it becomes 7 minus a negative 1, because yp is actually negative 1 right there. So 7 minus negative 1 over 2 minus 6. 2 minus 6. Therefore, the gradient of PQ is 7 minus minus is plus. So that is 8 over 2 minus 6 is negative 4. 8 over negative 4 is negative 2. And basically that's the gradient of the line is negative 2. All right, I think we need to see the question up here. Undo. Oh Lord. Don't know what's happening here. Don't know. All right, so right here. So moving up to the next part now. This is the question. Let's see the question here. So next part now is basically asking us to find the coordinates of the midpoint. Now remember, the midpoint is the average point, right? So it's the average of the 2 x values and the average of the 2 y values. So let's call the midpoint capital M. So midpoint let's call it capital M, is the average of the x values and the average of the y values between the 2 points. Right? And so that midpoint M, the x values are 6 and 2, you average them, and the y values are negative 1 and 7. You average those as well. But I understand that. And then that point, midpoint, is therefore 6 and 2 is 8. 8 over 2 is 4. And then 7 minus 1 is 6. 6 over 2 is 3. So the midpoint is 4, 3. And then the next part down here now is asking us to do the equation of the perpendicular bisector of PQ. So let me sketch that basically so we can see what we're actually dealing with. The perpendicular bisector. What do they mean by a perpendicular bisector? So the perpendicular bisector, perpendicular means perpendicular, bisector means it passes through the midpoint. So we want the line that is perpendicular to PQ and also passes through the midpoint of PQ, right? So the gradient of PQ was what again? Negative 2. All right, so let me sketch it, do a little sketch. So PQ is basically like this. All right, so it's 6, negative 1. All right. So let's say PQ is like this. Let's say this is PQ. Right, so let's say this is the P and this is the Q. Right? The midpoint is M right here. The middle point is M. And M has coordinates 4, 3. And the line that we're really trying to find, use a different color for that line. Let's use red, that color. The line that we're really trying to find, which is called a perpendicular bisector, now is this line. this is the perpendicular bisector. That's the perpendicular bisector we're trying to find. So to find the equation of this perpendicular bisector, we need to know two things about it. To find the equation of any line, we need to know two things about the line. We need to know the gradient, and we also need to know a point. We have a point already, it passes to the point M. But to find the gradient, we have to use the fact that it is perpendicular to this line that we know. And perpendicular lines have what we call negative reciprocal gradient. So let's say we call the perpendicular line now line 2. Let's just call it line 2 so we can reference it. Because they are perpendicular. And let's put it up here. Right? Line 2 is perpendicular to PQ. Therefore, the gradient of line 2 is minus 1 over the gradient of PQ. That's the relationship between perpendicular lines. And to do this calculation, it means that we can put the minus 2 under here. I can remember the gradient of PQ. Remember the gradient of PQ is the gradient of PQ that we did before up here. The gradient of PQ, remember, is negative 2 up here. Alright? And so we can put the negative 2 under here and put it as minus 1 over minus 2, which then becomes a half because 2 is cancelled. Or we can use the minus 2 down here as a gradient and flip this and change the sign. You write the minus 2 as minus 2 over 1. And to the negative reciprocal, you flip this, flip, and flip, and change the sign. Flip it and change the sign. Talking about the minus sign. That's how we do this calculation. That's how we do this negative reciprocal calculation. So if you flip this, it will first become 1 over negative 2, and you change the sign to 1 over, change the sign to positive, so it will become 1 over 2. So this calculation up here could have been done easily using the flip it and change the sign method that we did in class. All right, that's just a quick way to do it if you don't need to show that working. Flip it and change the sign. I wish I left that there now. Let me see if I can do it. Come back. The same thing, erase not coming back. Anyway. So the gradient is a half. So this gradient of the perpendicular line is a half. And so the equation of that line now, equation of the perpendicular bisector is y minus ym, because it passes to the point M, equals the gradient of the perpendicular line, which we call line 2, into x minus xm, because m is a point. So using that formula, that's called the point gradient formula. And so it's y minus the y value at m up here is 3. So it's y minus 3 equals the gradient is a half into x minus the x value at the point m is 4. So we'll put 4 there. And to make the calculation kind of easy, what we normally do is get rid of the fraction, multiply the denominator across this side, and multiply the numerator inside here. All right, just so we know what all these fractions we're working with. So multiply the 2 across here, we get 2y minus 6 equals, and multiply the 1 in there, we get x minus 4. And then now, it's just a matter of transposing the 6. So we get 2y equals x plus 2. But when the 6 come over here, we're going to become a positive 6. All right, so the plus 6 minus 4 is positive 2. Basically, that is the equation of that perpendicular bisector. 2y equals x plus 2. If you divide 2 by the 2 to get it in the standard form, if you divide 2 by the 2 to get it in the standard form, then it would basically become the same as y equals half x plus 1. So the gradient is a half and the y-axis intercept is 1. So we could have written it like that as well. All right. All right, that's that. So let's move on to the next question. Remember, if you don't understand something, you stop me right away. All right, so we're at this question now. Okay. So now at this question. So this question tells us that triangle PQR, that's the outer triangle, and triangle STR are similar triangles. What the relationship with similar triangles? Similar triangles have the same three angles, but the sides might not be the same. Right? So it's two triangles where the sides are different, but the three angles are the same. So it's basically like one of the triangle is an enlargement of the next one. So it means that this triangle up here is similar to the triangle inside here. So when you have similar triangles, the ratio of the corresponding sides are equal, and also the three angles are equal. All right. So if I were to extract the two triangles so that we can also have a look at it, one triangle is basically this one, something like this. This is R, T, S. A larger triangle is just basically same as that, bigger. This is R, T, Q. What happens is that the ratio of the corresponding sides are equal. But let me show you some other information here. These two triangles are similar because this line inside here is parallel to this line. So whenever you have an outer triangle with a parallel line inside, that line inside will divide the lines at the cross in the same ratio. So it crosses this line is in the same ratio as this. That is, mute your mic, please. Mute your mic. So that is good information to know. Right? So what it means is that if, for example, this side is 1 to 2, then over here is 1 to 2. Same ratio. It divides the lines in the same ratio. Right? If this line is 2 to 3, then this line is in the same ratio, 2 to 3. That is the ratio. And I'm not talking about the length of the lines, no, the ratio. It divides the lines in the same ratio. All right, the same ratio. The 2 and the 3 is not the length of the lines, it is a ratio of the length of the lines. The ratio. So it means that this piece down here will be 2/5, and this piece up here will be 3/5 of the 3/5 of the line. Similarly, on this line, whatever the length is, this would be 2/5 of the line, and this would be 3/5 of the line. Right? That's what happens. So that is good information to know. Can be very useful when doing some questions. All right. In addition to that, the ratio of corresponding sides in the triangles are equal. Three angles will be equal. So if this triangle has angles X, Y, Z, then this triangle will have the same three angles X, Y, Z. All right. And if you think about sine rule, right? If you think about sine rule, remember sine rule is a relationship between the angle and the side opposite, right? Then the ratio of the corresponding sides will be equal. So for example, this length over this length will be equal to this length over this length, right? Another ratio. This length over this length will be equal to this length over this length. The ratio of the corresponding sides are equal. This length divided by this length will be equal to this length divided by this length. The ratio of the corresponding sides in similar triangles are equal. So it's a matter of make sure that you recognize the sides on the similar triangles. All right, so let me draw them in two different colors so we can see what we're working with. All right, so let me see. Let me draw the outer one in purple on this. And I'm going to use a different color for the other one. Other one is going to basically be this one now. Let's draw it on the inside here. Right, so those two triangles, the purple one on the outside and the purple one on the purple one on the outside. Right, so those the big triangle, the big purple triangle and the orange triangle are similar triangles. The ratio of the corresponding sides are equal. All right, so that's just some information for us to remember. All right, so let us go now. So the question says, complete the following statements. In the diagram above, the corresponding angles of triangle PQR and triangle STR are equal. That's what I just said about these two triangles, those two similar triangles. The corresponding angles are equal in similar triangles. So you put equal here. Equal. And the something of their corresponding sides are the same. The ratio, that's what I just explained a while ago. The ratio of the corresponding sides is the same. The ratio, R-A-T-I-O. R-A-T-I-O. Good. The ratio of the corresponding sides are equal. Right, so the angles are equal, but in terms of on the sides, it is a ratio of the sides that are equal. All right, so let's go again now. So the question says, in the diagram not drawn to scale, RS is 15. So what we're going to do is put on the dimensions on it. All right, so RS is 15. So it means that this piece right here is 15. So on a small triangle, the RS is 15. Let's put over here as well. And SP is 9. So the right here says SP. This is 9. So that means that the large triangle is 9 plus 15, which is 24. All right. So it means that on the last triangle, RP is 24. Right? So we can compare those two triangles now, the big one and the small one that I've drawn. Right? And then it says ST is 12. So ST, which is across here now on the small triangle, is 12. So on the small triangle here now, this is 12. And the question is asking us for PQ. So the question is now asking us for this length PQ that we don't know. Let's call length PQ. Let's just call it PQ. This length is PQ. And we're trying to do that. So what do we know? The ratio of corresponding sides are equal. So it means that PQ over 24 equals 12 over 15. Simple as that. The ratio of the corresponding sides are equal. Right? If we didn't draw those small diagrams, we could still see it on the big diagram. Right? The long side on this base over the long side on this one is equal to the long is equal, all right, let's call it base. Base over side up on the big triangle would be equal to base over side up on the small triangle. The ratio on corresponding sides are equal. So all you need to do is identify what are the corresponding sides and you're good. All right, that's all you have to do. So what it means, let's set it up there. It means that PQ, the ratio of the corresponding sides are equal. So I'm going to put PQ over 24 equals 12 over 15. And so to get PQ, let's multiply the 24. So PQ will be equal to 12 over 15 times the 24. You multiply the 24 over here. It's like you multiply both sides by 24. And you're going to get PQ. As simple as that. 12 divided by 15 times 24. And that is 19.2 centimeters. 19.2 equals 19.2 centimeters. And basically that is what PQ is. Very good? All right, so very good. You must stop me if you don't understand something, right?
Yes, sir.
Good. Let's continue. right, so moving right along. So we'll come up to this question now, which clearly is an enlargement. Right, that clearly is an enlargement. Once you see that diagram. All right, let's see what they say. Question says, the graph below shows triangle DEF and its image D prime, E prime, F prime after a transformation. All right, let's analyze the transformation before we start. All right, so this looks like a rotation and it could be a reflection. So we want to decipher which one it is. It is not an enlargement, because if it was an enlargement, there will be a change in size. And it is not a translation, because the translation don't turn the object, just move it from one place to another. Clearly, we have some turning here. And we can know the angle and direction of the turn before we even do anything. Right? And it could be a reflection. So let's decipher if it's a reflection or a rotation. Now, to decipher if it's a reflection or a rotation, we can just check the orientation. If the orientation is reversed, we know it is a reflection in a line. If the orientation is not reversed, then we know it's a rotation. Remember, reflection and rotation can look alike sometimes. You always have to check. So if you look at the orientation letters, DEF on this is this direction. DEF is this direction, this way. DEF. And on this one, DEF is the same direction. So the orientation is the same. Orientation is anti-clockwise. So there's no change in orientation. So we know we have a rotation. So we know that just by doing that, it is a rotation. All right? Because a rotation and reflection can look alike. Next thing we can decipher is the angle of the rotation. And you can look at that by looking at one side. So if we look at DE, for example, DE is a horizontal line this way. But on this image, DE now is a vertical line this way. So you know that this rotate, the head is pointing up. I mean, it was pointing right first. So the head has rotated. So from a horizontal line, you go to a vertical line, you know that the rotation is 90 degrees. And the direction of rotation is from the head goes from here to up here. And so it's an anti-clockwise rotation and it's 90 degrees. So that's a 90 degrees anti-clockwise rotation. So the next thing we need to know is the center. Rotation as a center, right? Rotation as a center. Now, normally at this level, the rotation angle is normally the origin. So I'm going to check if the rotation angle is the origin. And you can just look at the distance from the origin of the points. So if you look at the point here, and look at D first, that would be the vector from O to D. And this is now D. Those two lines are the same length. So it's like this line was rotated to here. That would be 90 degrees. So far that point is looking like a 90-degree rotation about the origin. As observation, you can do this by now. You don't need to make it complicated. If you look at the E line is this. And it rotates to here. Again, if you look at it, this is 90 degrees. And the length of this line is 1, 2, 3, 4 across, 1, 2 up. And this length of this line is 1, 2, 3, 4 up and 2 across. So those two lines are the same length. Right? So it's clear that it is a rotation anti-clockwise and the center of the rotation is the origin. It is obvious. Look at this one. Look at this one. Look at F. F gone up there and it rotates to here. You can see that that's a 90 degree right there. And the length of this line can be broken down into 1, 2, 3, 4, 5 by 1. This is 1, 2, 3, 4. No, sorry, 1, 2, 3, 4 by 1. And it is 1, 2, 3, 4 by 1. So you know that the length of the line are the same. So that confirms the rotation anti-clockwise 90 degrees about the origin. So we know that. So we can start answering the questions now. So you want to establish those things before you go on. Because they're going to ask you that, you know, must ask you that. So state the coordinates of E. So E clearly is 4. Right? Here must be 4. 4, okay, going up by 1. 1, 2, 3, 4. 4, 2. So E is a point. E is a point 4, 2. E is a point 4, 2. All right, that's the first part. A free one mark that. The next part says describe fully the transformation that maps triangle DEF onto triangle D prime E prime F prime. So this is a matter of describing what we just did. We just observed. We have decided that it's an anticlockwise 90-degree rotation about the origin. So you just need to write that. So you can write it like this: triangle DEF maps onto triangle D prime E prime F prime by an anticlockwise 90 degrees rotation about the origin. Rotation about the origin, right? And you make sure all the components are up there. So it's a rotation, so I've given the name, and rotation has 3 components. It has a direction which you have given, it has an angle which you have given, and it has a center. So you have to always make sure that your description has the name and the component. You cannot just give the name alone, because the question said fully. So you describe a transformation fully, you give the name, and you also give the components. You cannot just say it's an anticlockwise rotation. You cannot just say it's a anticlockwise 90. You have to give everything. You have to give the angle, you have to give the name, the direction, the angle, and the center. Because it is a rotation, it has 3 components. If you had an enlargement would only have a scale factor and a center. If it was a translation, you just give how many units left or right, how many units up or down for translation. And if it's a reflection, all you need to do is state the equation of the mirror line, or state the mirror line. Like you might say a reflection in the x-axis, something like that. That's all you have to do. All right? You have to remember, you give the name and the direction. All of those things in your notes. All right? You must know transformation notes. It's there. All right, next part now says, on the grid above, draw a triangle D double prime, E double prime, F double prime, reflection of D prime, E prime, F prime in the x-axis. So basically, they want us now to reflect. They want us now to reflect this triangle up here in the x-axis. All right, now remember, when you're doing your reflection, you're reflecting over the x-axis, which is this line, right? You have to use image distance equals object distance. And you do your reflection 1 point at a time. Don't try to reflect the entire triangle all at once. You make a mistake. All right, so we're going to reflect the point D first. So D is 1 unit to mirror line. It's going to go 1 unit on the other side. All right. So basically D is coming right here. So that is D double prime. Similarly, F is 1 unit from the x-axis, going to go 1 unit on the other side. So it means that F double prime is right here. And then E now is 1, 2, 3, 4 to the mirror line. And so it's going to go 1, 2, 3, 4 on the other side. All right, so you're coming right down to -4. Right down to here. That is E double prime. Do it 1 point at a time. And then once the 3 points are in place, you just basically use your ruler and draw the triangle. That's all you have to do. Use your ruler now and draw the triangle with your ruler. And that's it. That is all the images. Simple as that. All right, let's move on. Next question. All right, this question now. Let's put it up here. So this question is a scale question, right? Remember, scale questions can be done simple ratio questions. All right, so scale of a map, and it's a map question. Now, this question usually have area in it, but I don't think this one have no area in it. Right? When I read it, you have any area. So don't need an area scale, but I can still show you how you will do an area scale if the question had area in it. Something I will do all the time. Let me do the ratio thing up here so you can see what they're doing. All right, so the ratio is 1 to 25,000. Now, usually the map is going to be in centimeters. The distance on the land is going to either be in meters or in kilometers. This one is in kilometers. So what you want to do, you want to establish a relationship between a centimeter on the map and kilometers on the land. If it was area, you want to establish a relationship between 1 centimeter squared of area on the map and the kilometer equivalence kilometer square on the area. So you can do the question as a ratio. So we're talking about distance. Right? Map to land. It's gonna be 1 centimeter to 25,000 centimeters. So 1 centimeter on the map is 25,000 centimeters on the land. This is map to actual. That's what it is, map to actual. Right? And then what you do now, you want to convert this 25,000 centimeters to kilometers. First, you convert it to meters. I remember 100 centimeters make a meter. So it means that 1 centimeter would be 250 meters if they ask anything in meters. And then to get kilometers, it will be 1 centimeter on the map. Divided by 1,000, we get 0.25 kilometers. And basically that is the ratio between them. So 1 centimeter on the map is equivalent to 0.25. If you're doing area, if you want an area scale, right? Area scale. All you need to do to get area scale is square this ratio in order to square it. Just square, because area is a square dimension. So just square this ratio. Just square this. Just square that ratio. And what will happen, you will get 1 centimeter squared to 0.25 kilometers squared. You square both sides of the ratio. Right? Because 1 centimeter is 1 centimeter. Multiply one side by 1 centimeter, multiply the next side by 1 centimeter, which is 0.25 kilometers. And so it will come out to that 1 centimeter squared area on the map. You square this now, 0.25 squared would be 0.0625 kilometers squared. And so you can use this ratio, anything relating to area. And you use this ratio, anything relating to distance, right? So you can do that. So establish those ratios. Now, this question now says, what did I do? Go back. All right. It says, Underlane and Jersey are 31.8 centimeters apart on a map. Determine in kilometers the actual distance between them. Underlane and Jersey, the actual distance is the distance. So we're going to use a ratio. All right, so it's simple. 1 centimeter to 0.25 kilometers. Right? Let's write that back. 0.25 kilometers. You want the 1 centimeter to become 31.8. So I have to use multiply by 31.8. So I'll have to do now, multiply the ratio by the 31.8. Because I want the 1 centimeter to become 31.8. So multiply both sides of the ratio by 31.8. So it means that 31.8 centimeters on this side. And multiply the 31.8 times this 0.25. and you get 7.95 kilometers. Therefore, the answer is 7.95 kilometers. That's the distance between these two places right here. Simple as that. All right, multiply the ratio. Once you establish a ratio, you multiply and divide the ratio to get what you want. This part now says the actual distance between Clifton and Jamestown is 22.7 kilometers. So they're giving us the actual distance on the land now. Hold on a second. Is who this calling me now? Hold on a second. Hello? Lana. I'm doing a class now, you know. All right, cool. Right. So, all right, back to this now. So they'll give us the actual distance on the land now. So if we go back to the ratio, distance, so the distance ratio we're working with again now. All right, so we're working with distance ratio. So come back 1 centimeter to 0.25 kilometers. And this time now you want the kilometer side, the actual side to become 2.75. All right, quite simple. All we have to do is make it become 1 first. And then after we make it become 1, we make it become 2.75. All right. So if you have 0.25, I want to become 1, you can multiply by 4. Right? Or you can say divide by the 0.25. So to divide by 0.25, we use the same as say multiply by 4. So I want this side to become 1 first. So since it's 0.25, I can multiply by 4 first. Multiply by 4, my ratio become 4 centimeters to 1 kilometer. And then I want the 1 kilometer now to become 2.75. Doing the easy way. So I'm going to multiply again now by the 2.75. When I multiply by the 2.75, I get 4 times the 2.75 equals 11. So it means that 11 centimeters on the map is equivalent to 2.75 kilometers on the land. And so the answer in this part is this, 11 centimeters. 11 centimeters is the answer. The distance on the map is 11 centimeters. All right, this up here was the answer for this part. Oh Lord, oh Lord, let's write it back. This was to 7.95 kilometers. All right, this was the answer up here. All right, if you have any questions, just let me know. All right, so we'll do the scale question as a ratio question, which is just to multiply and divide by values to get what you want. That's the easy way to do ratio questions. All right, as we did in class. All right, so this question now. So for this question now, so we'll do that already. So we'll come to this diagram now. It's ready. All right, so the question says, the diagram below shows a square ABCD. So that's a square drawn inside a circle. So the vertices of a square lie on the circumference of a circle. The length of a side of a square is 11 centimeters. So it means that this side is 11. Let's put it up here. This side is 11. This is 11. This is 11. This is 11. This is 11. All right. So the question says, show that the length of the diameter is 11 root 2 centimeters. So basically, they want us to find the length of this diameter. To find out the length of that diameter, we can work in this triangle and use Pythagoras' theorem. All right. So the diameter AC we're going to use. So the diameter AC. Diameter.
That's the easiest part.
Move your thing, please. Diameter AC equals, using Pythagoras' theorem, becomes the square root of 11 squared plus 11 squared. That's what it becomes. Square root of 11 squared plus 11 squared. Triangle there at that mark, right? And so that becomes the square root, because I'm trying to get the answer to look like this, you know. So I have to work with the square root. I don't think they should have said a question like that, but that's what they do sometimes. don't need these series operation unnecessary, but it doesn't matter still. Anyway, it becomes the square root of 2 times 11 squared. Right? Of 2 times the square root of 11 squared. If you break it up, right? Because if you have a square root of a product like square root of AB, square root of AB is equal to square root of A times the square root of B. Right? So we need to break this out. And so this becomes square root of 2 times 11. Because the square root of 11 squared is 11, which can be written as 11 times the square root of 2 centimeters, and that's it. If you don't understand, let me know. That is what you have to do. All right, and not work out the value. They want you to write it like that. 11 times the square root of 2. So that's what the square root of 2 comes up about. All right, so moving up. Next part now wants the area of the circle. Area of the circle. Now remember, area of a circle. Area of a circle is pi times the radius squared. But they didn't give us the radius. That is the area of the circle. It's pi times the radius squared. But they didn't give us the radius. They gave us the diameter. So let's establish a formula for the diameter. The radius is the diameter divided by 2. So the radius squared is the diameter squared divided by 4. So this formula for area of the circle becomes pi times the diameter squared over 4. Since the diameter we know. The diameter is 11 times the square root of 2. And so the area of the circle is, they tell us to use pi as, did they tell us to use pi as anything? Or they wanted to do decimal place, but they didn't tell us what to use for pi. So we can use the pi on the calculator. Right? Because they didn't tell us what to use for pi. So we're going to use the pi on the calculator. So it becomes pi times the diameter, which is 11 times the square root of 2 r squared divided by 4. And you put that in the calculator, you work it out, it really becomes the calculator. It becomes pi times 121 times 2 divided by 4. The 11 squared is 121. The square root of 2 squared is 2. All right, so use the pi on the calculator. Pi times 121 times 2 divided by 4 divided by 2. And so that is 190. You say what? One decimal place? Decimal places. So it is 190.07 centimeters squared. All right, that's it. All right, next part now wants the area of the square. So let's call that AS. The area of the square is simply equal to 11 squared. 11 times 11. Right? 11 squared, which is 121. So the area of the square is 121 centimeters squared. And the next part now wants the area shaded. The next part wants area shaded. So if we look at it, right, the area shaded is basically 1 basically 1 out of these 4 segments. These are called segments. They are between a chord and the circumference is called a segment. There's 4 of them. So we can find the total area of those 4 and then divide it by 4 to get the one that we want. Simple as that. All right. So the area shaded is 4 of, all right. 1/4 of those 4. And all of that shaded region will be the area of the circle minus the area of the square. So we can write a simple form for the area shaded. The area shaded equals the area of the circle minus the area of the square divided by 4. But understand that? But understand that?
Yes, sir.
The area that they gave us is just 1 out of the 4 parts. So it's divided by 4. So that reduces to equal to
Yes.
the area of the circle
Kept some faith.
is 190.07. Minus the area square is 121. That gives you all of the areas around the square, between the square, the 4 segments that give you. And you divide that now by 4, because you only want one of them. That will give you the answer.
Okay.
So it's 190.07 minus 121 equals, and you divide now that area by 4. And so you get 17, so to 2 decimal places, 0.27 centimeters squared is the area. Centimeters squared. All right, and basically that's that. All right, so moving up. All right, so question number 7. Let's do it up here as well. Question 7. So question 7 gives us this diagram, and it says, the table below shows the number of bananas to the nearest ton produced annually on a farm over a period of 6 years. So we can see that from 2010 to 2015, 6 years. It says on the graph paper provided, 21, draw a bar chart. Remember, a bar chart must be spaced out. There must be a space between the bar. There must be evenly spaced, and all the bars must be of the same width. And then the height of the bars corresponds to the frequency or the value that they're measuring. All right, draw a bar chart. And the same was using given data using a scale of 1 centimeter, 1 year on the x-axis, and 1 centimeter, 25 tons on the y-axis. All right, so we'll need to draw that bar chart on this graph right here. So let's see if we can put it up here. This thing not getting smaller. I mean, it's not reducing in size. So let's see what I can do. All right. So let's scale it up. So I'm gonna let this by my x-axis down here. See if we can try it. Turn off your mic, please. Somebody turn off your mic. That's my x-axis. Time axis in years. And that's my y-axis up here. All right, and the bars are going to be spaced out. I must use 5 centimeters for a year. All right, so I'm going to use this as my first bar. So that's my first bar for 2010 right here. And then the next space over here is going to be my second bar for 2011. Then my next bar over here is going to be 2012. Then my next bar over here is going to be 2013. And my next bar over here is going to be 2014. My next bar here is going to be 2015. All right, and then the bars must go by the body. The vertical axis is 25 tons, so this is going to be 25, 50, 75, 100, 125, 150, 175, 200. How much is going up to? Going up to 275, 200, 225, 250, 275 is the highest bar. 275. Good. All right, so the first bar going up to 150. So easy. Let's draw my lines up to 150. Use your ruler and do it, and don't do it in free and like me. That's the first bar up to 150. The second bar must go up to 225, 275. So the second bar going all the way up to 275. So this color, this it all the way down here. 275. Right, that's the second bar. Use your ruler and do it. Third bar is at 100. 100 bars must be spaced out. It's a bar chart. So you must have same space between the bars, same as the width as the bars. A bar chart, not a histogram, and not for continuous data. The next one is at 40. So 25. So every line is 5. Right? Every small line is 5. So this is 25, 30, 35, 40. So 40 is right here. That's 40. Right, 40 is right there. The next one is 125. So 125 is here. 125. 125. And the last one is 210. This is 200. Remember, every line is 5. So 200, 210 is right here. So it's 210 that. And I will come down. All right, come right down. Come right down. Use a ruler and do it. All right, don't use a friend like me. So basically, that is a bar chart. Done. All right, and you can label it up. Bar chart or question what a bar chart showing tonnage of something. You can label up the bar charts. Write it up. Down here is the years. Up here is the production. Up here is production. Up here is production. Production in tons. Production in tons. All right. All right. So basically that's that. So let's go back now to the question. So the next part now wants us to determine the range in the ton, range in the number of bananas produced between 2010. The range is the largest production minus the smallest production. That's the range. So the largest, look up here, the largest is this, and the smallest is 40. All right, so we can do that as a range. So the range, come back down here. The range is 275 minus 40, which is 235 tons. 235 tons is the range. All right, hold on a second. A second.
Well, go on. What?
All right, guys. Sorry about that. They want to let's hear the bathroom. All right, so we'll get back to this now. Right. So that is the range, right? Next part now said, during which year was there the greatest production of banana? So the greatest production clearly is in 2011. You can see that. 2011, right? That's 2011. It was 275. 2011. All right, that was the year. How is this information shown on the bar chart? So if we go back up to the bar chart, it is shown by the highest bar. Here, the tallest bar. Tallest bar is this one that represents the highest production. One of the tallest bar or the highest bar. All right, so we can say the highest bar, the tallest bar. All right, where are we? Okay, so going back up here. Right. So how is this information shown on the bar chart? The tallest or the highest bar? All right, so since it is shown on the bar chart as the highest bar. Next part now says, between which two consecutive years? 2 consecutive years means 2 years back to back. That's what consecutive means. 2 consecutive years means back to back, side by side years. Between which 2 consecutive years was there the greatest change in the production? Between which 2 consecutive years was there the greatest change in the production? All right, so you can actually get that from the table up here by looking at the differences. Right, you can look at the differences and get it up here. Right, or you can look at the bars and see which 2 bars are the biggest difference between them. Right, which 2 bars are the biggest difference between them. So let's go and look at the bars so we can see that. We can look at the table here. So we can look at the differences. And so the difference, let's put in the differences. I can get it from the figures. So the difference here is 125. What's the difference between this and this? 125. And then this is 175. 175. This one is a drop of 60. Let's put a minus, plus. And then this one now. This one now is a plus 80, plus 85, plus 85. And then the last one is a plus 85 again. Another plus 85, plus 85 is that one. All right, so the biggest change is right here. That's the biggest difference, you know. It's a change. Remember, I said increase or decrease, and it's a change. So change is whether increase or decrease. So the biggest change is from 2011 to 2012. That's when you have the biggest change. All right, the biggest change was 2011 to 2012. 2011 to 2012, 2 consecutive years. And I said, now, how is this information shown on the bar chart? So it's shown by the largest difference between 2 consecutive bars, right? Greatest difference between 2 consecutive bars. The greatest difference between 2 consecutive bars, which is from here to here. Between here and here, you can see it. The difference in height between these 2 bars, here and here. we had the biggest difference. All other bars kind of, the difference is not so large, right? So we have 2 consecutive bars with greatest difference in height of 2 consecutive bars. All right, so I write that greatest or largest difference in height. Greatest difference in height of 2 consecutive bars. 2 consecutive bars on your bar chart. That's where you know the where you have the largest change. 2 consecutive bars side by side, which are the largest difference in height. All right. Then that was the bar chart. That was the graph. And then what else are we supposed to do? Next part now says, give one reason why the bar chart is unsuitable for predicting the number of bananas for 2016. Because it is not a trend graph, right? It is not a trend graph. Is this bar chart is usually used for discrete data, not continuous data. And you would normally use a trend graph to predict. So it's not a graph showing upward and downward trend, just showing the actual production. You're not seeing the trend, right? You're not seeing the upward and downward trend of the data. Discrete data, right? It's basically discrete data. You're just having the production in the individual years, but there's no connection between the years from one year to the next. And that's why we separate them on the bars, right? And so it's not showing upward and downward trend. Bar chart does not show upward, downward trend, which can be projected to 2016 as would have been the case with a line graph. So in other words, if it was a line graph, we could have projected to 2016, right? If we want to cancel the bar chart, is used for so it's properly discrete data. It's used for discrete data, not continuous data. As a continuous data usually can project. They could have put this on a line graph to still, and then do a projection, They could have put this information on a line graph, right? So, continuous data. So the key thing is that a line graph would have served us better to project onto the next year, 2016. A line graph would show you the upward and downward trend. And you could basically look at the line graph and see overall how the production is trending. If it's trending upwards generally or trending downwards. That's what the line graph to give you a visual representation of the upward and downward trend. The bar graph doesn't do that. All right, so basically that is it. So if we wanted to know what the production in 2016 would have been, and we wanted the statistical diagram to help us, the one that would help us would be the line graph. But they decided to draw a bar graph with this data. All right, so basically that is that. All right, so next question. Next question. This page has nothing. All right, so let's move up here. All right. This page has nothing. All right, so we'll come to this one now, which is the question 8. These pattern questions. All right. All right, so this question says the sequence of figures is made up of unit squares. Unit means each side of the square is one unit. That's what I mean by unit square. So each side of a square is 1 unit. All right, that's what I mean by a unit square. Each side is 1. All right, that's what unit stands for. All right, so it's made up of unit squares with unit side. Well, it said with unit side, meaning one unit long. It says the first 3 figures in the sequence are shown. Right? So they start with this, and if you notice, they basically add a square on each side of the first square. All right, to get this one, they put a square here, one here, one here, one there. All right, and then now to go from from the second one to this one, I put a square here, 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 here. So they basically keep adding 4 squares. From diagram to diagram, they keep adding 4 squares. All right, and I want us to draw the next one. So to draw the next one, essentially you're going to draw by the third one, and then you're going to put a square here, one here, and one there. And that will be our 4th one. We'll have to draw it from scratch. All right, so it's almost like you draw the 3rd one first, and you just add on the additional square. That's how we get the 4th one. So let me use the block. Let me use the block for that. So in the block. No, we have in the block. All right, let's use this thing closest to the block. And maybe it have the block and I just don't know how to get it. So anyway, let's draw this one. Let's draw about the 3rd one first. And you don't need no rule and the exam to do this. You can just do this with a free and I'll move on. But I waste time, but yeah, draw with a ruler. See, I'm drawing to my free hand. You can draw it to the free hand in the exam as well, just like that. Alright? You're not getting any marks for aesthetics on these questions. And then now we need the 4th diagram is to put on the additional square. Right, so let's draw the additional one back in the purple. So you can see it. So let's use back this for the additional one. So that becomes the 4th one by us just extending this. Put another square onto here. So that whole diagram is our figure number 4. So over here now, n equals 4. Over there, and that's that. All right. Then it says, study the pattern of numbers in each row of the table. So each row relates to one of the figures in the sequence. Some rows have not been included in the table. So they want us now to look at the table and study the table. All right. So I like to fill out my formula first. I just believe it's easier if I fill out this part first. Observe the formula, if there's a formula. And these questions where you're adding the same number of items each time, it's easy to come up with a formula. So if you look at the figures here, these are the figure numbers. Figure 1 for figure 2, figure 3, figure 4, and each one relates to the diagram up here. Same diagram up here, right? Each one relates to the diagram up there. So if you notice from here to here, add 4. I add in 4 squares, and from here to here, you add 4 again. Similarly, from here to here, now you're adding 8 because when you put on, let's go back on this. In terms of the perimeter, you're adding 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But anyway, you're adding 8. You're adding 1, 2, 3, 4. It doesn't matter. If you look at it, you're adding 8. So from here to here, you add 8. And from here to here, you're adding 8. All right, so you keep adding 8 on this side and keep adding 4 on this side in that column. All right, so that information is going to become relevant to the formula that I'm going to try to get first. So since I'm adding 4 in the middle column, 4n is a part of my formula because I'm adding 4 each time. But the first diagram has 1 in it. First diagram is where n equals 1. So if n equals 1 right here, I'm going to equal 4. 4 times 1 is 4. So to get the answer to come down to the 1 that is up here, I have to subtract 3. So therefore, the formula is 4n minus 3. Because when n is 1, I need to answer. When n is equal to 1, I need to get 1 right there. So, all right. For this one now, I am adding 8 each time. Adding 8 each time. So because I keep adding 8, it means that 8n is a part of my formula because I'm adding 8 each time. In the first figure, where n is equal to 4, 8 times 1 is 8. I have to now subtract 4 for that first figure to be 4. And that's how you do it. If you don't understand, let me know. But basically, that's how we get the formula. All right, I'm assuming that you understand, so I'll just proceed. All right, so let's fill out this section now and go down the line. Now that we have the formula, let's fill them out. I like to use my formula, very useful. So I like to get my formula first. So here now, this is just from figure 3 to figure 4. So all I'm going to have to do is add 4 right here, as was happening in the case before, right? Just keep adding 4. If you want, you can use the formula. All right, so if I add 4 to this, I'm going to get 13. And if I add 8 to this now, this is where I'm adding 8. So I need to add 8 to get to this one, because it is the next figure, figure 4. All right, so I just need to add 8, and I will get 28. And then I can test if it works with the formula here and also there. I can test the formula and see if it works. So right there, the formula would give me 4, would be 4 times 4 minus 3. Minus 3, not 30, minus 3. It is 60 minus 3, which is 13. Well, not there. Here, so. Not there, here, so. Here, so. All right, and over here, it would be 8 times the figure number of 4 minus 4. All right, so 8 4 is 32. 32 minus 4 is 28. So you see the formula works. All right, and then now for this one now, I'm trying to find the n to go there. I know that the formula is equal to 45, so I can use the formula to work out the n now. As easy as that. So for this one, I'm gonna say my 4n minus 3 is equal to 45. I'm trying to find the n for here. So my 4n minus 3 is equal to 45. So that means I add the 45, I get 4n is equal to 48. And 48 divided by 4 is now 12. So n equals 12. So right here, the n equals 12. And then if the n equals 12, I can put the n equals 12 over in the formula over here. So it becomes 8 times 12 minus 4. And that is what? 96 minus 4. 8 times 12 minus 4 is 92. So right there is 92. And then down here now is simply where n equals 30. And so the formula for right here becomes 4 times 30 minus 3. So that's 120 minus 3 is 117. And over here, it is simply 8 times 30 minus 4. That's 240. 8 times 30.
236.
236. Okay, so I get all those values. So that's why the formula is very helpful. You don't have to go try reason out anything and complicate the thing. You just make the formula work for you. If you can work with a formula. If you don't work with a formula, you have to use some reasoning method. Most of them, if you establish a formula, you're good.
I understand the formula.
Yes, sir. Oh, you make a formula.
All right, do you understand the formula? All right, so let's go again. Let's go again. Let's do this column first. The value is going up by 4. But I give it that?
Yes,
But I give
sir.
it that. All right.
Yes, sir. Yes, sir.
All right. So the value is going up by 4. So the value is going up by 4. It means that 4n is a part of the formula. So it's going to be 4n plus something or 4n minus something. Or it can just be 4n itself. What tells you what is plus or minus is the first figure. The first figure is 1. So the first figure is where n equals 1, you know. First figure is where n equals 1. So if n equals 1, this is going to be 4. To get it to be 3, you have to go to get it to be 1, you have to go subtract 3. So the formula is 4n minus 3, see it?
Yes, sir.
Yeah? Want to see it now?
Yes, sir.
All right, and for this one now, for the second one now, the second one is going up by 8 every time. And this method is only when you're adding the same thing or subtracting the same thing every time. That's how this formula works. You're adding the same thing every time. So this one now, you're adding the same thing every time. Good? So because you're adding the same thing every time, 8n is a part of the formula. So it's going to be 8n plus something or 8n minus something. What tells you if it's plus what or minus what is the first figure? The first figure is 4. Remember, in the first figure, the n equals 1, you know. So this would have been 8 in the first figure. Right? It would have been 8 in the first figure. But the final answer in the first figure is 4. So I'm going to subtract 4 to make it 4. You see that?
Yes, sir.
So that's how I'm going to get the 8n minus 4. So it becomes 8n minus 4. So the first figure tells you what you add or subtract. The first figure tells you what you must add. Jesus. Delete everything. Oh gosh. I deleted everything. Let's write it back. Oh lordy. So this was 4n.
Minus 3.
Minus 3. This is 8n.
8n minus 4.
Minus 4. And we said for here, we use a formula. I will get 4
30.
times 4 minus 3, which is how we get the 13. And for here, use a formula 8 times 4. 8 times 4 minus 4. So we get 20. How much?
28.
28,
sorry,
yes,
20,
man. So
yeah.
it's 28. And then here now, we say we work out this value by putting the formula equals 45. Formula in the middle equals 45. That's what we did right here. So we put the 4n minus 3 equals the 45. I'm trying to find the n. And so the n equals 21, right? 21. Yeah, 21. Because it becomes 48 over 4.
So
No, it becomes
12.
12.
Yeah, 12, sir.
12.
12. That's a me.
All right.
One, two.
So it becomes 12. So right here, so we know it's 12. Now after we know it's 12, we can use the 12 over here now. So it becomes 8 times 12
minus 4. Supposed to be
96
92.
minus 4, which is 92.
Yeah.
And then down here now is a simple case as for here, it becomes 4 times 30 minus 3, which is 117.
Yeah.
And for right here, it becomes 8 times 30 minus 4, which is what?
236.
236. All right, good. So that is that. All right. So moving right along now. Oh, that done. Easy question. All right, so we'll have 2 more to do now. Yeah, that done.
Yay.
Lazy, you know, so no about yeah. All right, come this one. Question 9. So I see that table. I know it's a proportions question, a variations question. All right, so this question says the table shows the pairs of values for x and y where y varies inversely. Y is inversely proportional to x. Remember, inversely means k over. So express y in terms of x and k. Simple as that. Y equals k divided by x inversely. This statement means y is proportional to 1 over x. If y is proportional to 1 over x, then y is equal to a constant over x. If that's said directly, it will be y equals k times x. But I didn't say directly, they said inversely. All right, so basically, I can leave that on the slide. I can leave that right here. And then if y equals k over x, we can get a formula for the k by multiplying by the y. Multiply the x up here and leave k as a subject. But we have to find k now. So it's useful to write this as k. I write this as xy equals k. But this is really the answer. No? This is the answer what they want. You know? This is the answer. Because they say write y in terms of x. So technically that is the answer right here. But this is useful for when you want to find k. All right, k will be the product of x and y all the time. K is a constant. Next part, so must calculate the constant. So to calculate the constant, use a known pair of values. So you can either use this pair or you can use that pair. It doesn't matter which one you use. The answer is going to be the same. All right, so the k is equal to x times y based on this. K is equal to x times y, which becomes basically 3 times 2, which is 6. Or we could have written k still equal xy. Use the other pair, other known pair, which will be 4 times 1.5, which is still 6. In any case, it is 6. And what that means is that the xy, so we can say therefore, xy will always be equal to 6, because k is 6 from this formula. Right? The xy will always be equal to 6. 6 is a constant, it's not going to change. Constant means it's not changing. The x and y values are not changing. So now we want to find, let's look up here. We want to find the value of a and the value of b. So I want to use this formula to find them. This formula now will help us to find those things. So the first one, a and b. The first one is when x equals a, y equals 1.2. So you put the values in the formula. It therefore means that a times 1.2 is equal to 6. So divide by the 1.2, you get a equals 6 over 1.2. So you get a equals, how much is that? 6 divided by 1.2, 5. A equals 5. That's the first one. The second one now, look at the table here. Second one here is x is 20 when the y is b. So the second one, x equals 20 when the y equals b. So you put them in the formula. So it means that 20 times b. So let's write the therefore. So we can say therefore, we put in these values in this formula now that I have in the table, this formula. Right? So therefore, the 20 times the b is equal to 6. So divide by the 20. So b equals 6 divided by 20. Which really, and since I give the question with decimals, that is 3 over 10, which is 0.3. You can give it with decimals. Since I put decimals in the table, you can put decimals in the answer. 0.3. And that's it. Good?
Yes, sir.
Good. All right, moving right along now. Next question. Next question give us this graph as a quadratic smile graph. You can see it. All right. So next question gives us this thing. All right, so that is the function right there. This question said the diagram below is a graph of function f of x equals x squared minus 6x plus 8 for values of x between 0 and 6, right? So values of x between 0 and 6 is the domain down here. Right. So basically, values of x between 0 and 6 means that they could have written it like this as well. X less than or equal to 6, greater than or equal to 0, and this is called the domain. Domain is the spread of your x values. Range is the spread of your y values. All right. All right. So basically, that is also the domain. So the domain is from 0 to 6. What the question says? Use a graph to solve the equation. So this equals 0 for solving. This equation leads to the roots. You solve a quadratic equation. This is called a quadratic equation. Quadratic equation. When you solve a quadratic equation, you find the roots. What are the roots? The roots are the x-axis intercept. X-axis intercept. So this equation is talking about this point and this point. Now this equation is in terms of x alone, you know. So the answer will be only the x values. All right. So basically talking about the x value here and here. And the question says use the graph. I said I don't want you to solve the equation. You're using the graph. So those 2 points satisfy the equation. So from the graph, the x will be equal to 2 and the x will be equal to 4. And this is the x-axis intercept. And solve the equation, you're finding the x-axis intercept. You see this thing where them have this equation equals 0 is the same as saying y equals 0. And y equals 0 is the x-axis. So what the x-axis is y equals 0. X-axis is y equals 0. So this guy is trying to find where the curve and the y equals 0 intersect, which is here and there. So there are several ways to look at it, really. All right, in any case, when you solve the equation, you're finding the roots, and the roots are the x-axis intercepts. All right, so basically that is that. Next part. Delete it again. I keep pressing the wrong thing. Jeez, right, let's go again. So, as I said, now we're solving this. You get the roots. Roots are the x-axis intercept. My x-axis intercepts. And this is called the quadratic equation. This is called a quadratic equation. When you solve it, you get the roots. And yeah, as I said, the x-axis is y equals 0. And solving the quadratic equation, essentially, let's not make the mistake again. This is y equals 0. Solving the quadratic equation is the same as solving simultaneously. Y equals 0. And you're also solving the curve y equals x squared minus 6x plus 8. So the point of intersection of the curve and the x-axis is right here and here. And there are several ways to look at it, as I was saying. All right, so in any case, the result is x equals 2 and x equals 4. This equation has x values alone in it, so you can't put a y. Just x equals 0, x equals 4. And so we define an x values on x-axis. The graph intercept the x-axis. All right, so let's not make that mistake again. It says no, right on the coordinates of the minimum point. The minimum point is right here. The graph turns. That is clearly 3, -1. So the coordinate of that minimum point is 3, -1. So the lowest point on the graph, 3, -1. All right, so that is the minimum point, 3, -1 right there. All right, 3, -1. Next part now says they want us to write this in this form. They want us to write this in this form. All right, go from that to that. So go from that to that by the process of completing the square. Now remember, the method that we use XTYT business because it changed the format of how to present this all the time. I don't want to get mixed up and make any mistakes. So we use a method where we use XTYT. So our format is to say A into X minus the X value at the turning point squared plus the Y value at the turning point. All the question are easy is that we already know that the A equals 1. And we know the turning point already. Right? We know the turning point already, you know. See there? The turning point is 3, -1. So we do have to do no work. All right, the minimum point, minimum turning point is XT, YT. Same XT and YT we go here, so and this one. All right, and it happens to be 3, -1. So it means that the XT value is 3 and the YT value is -1. And so therefore, this becomes x squared minus 6x plus 8 can be written as A, which is 1, into x minus xt, which is 3. Don't forget the square, and the plus yt is yt. Plus yt is -1. You don't have to actually work them out because you know the minimum point. You understand that? Yes, sir. Right. Normally you have to work them out. If you want to work them out, you can, but normally you don't have to work them out this time because you have you know the coordinates at the minimum point. Otherwise, you'd have to go and do xt equals minus b over 2a. And it would be minus, the b is what? 6, minus -6 over 2a, which is 2 times 1. So it will be 6 over 2, which is 3. So 3 there. Xt. Right? And let's do the yt as well. Yt would be 4ac minus b squared. Well, normally, as I told you, when xt is a whole number, you can record yt by putting it in there. So the yt, you can put it on here. The yt would be equal to, put the xt value would be equal to 3 squared minus 6 times 3 plus 8. And you get the same -1, I'm certain. Let's check it. 3 squared is 9. 9 minus 6 3 are 18. 9 minus 18 plus 8. Yeah, -1. So you can calculate them. You don't need to calculate them, right? Because you know the turning point and you know the a value is 1, right? You know the xt, yt value. So this time I didn't have to calculate them because you know the minimum point. Anyway, it says on the same axis, draw the graph of a straight line g of x. G of x equals x minus 2. Draw x minus 2. All right. So g of x is just like y equals x minus 2. So for this one, the gradient, we can use gradient and a point to draw a line. I can plot points, right? So the gradient would be 1, and the c is -2. So to draw this line, all we have to do is rise and run from -2. So rise 1, run 1 from negative 2, or rise 2, run 2. So let's go back and see we could draw that line quickly using the y-axis intercept and a point. The y-axis intercept, that's the known point. So I want to draw that graph. All right, so the graph, the line that we're drawing passed through this point right here, the negative 2. Passes through negative 2. Right here. Line that we're drawing. And then notice the scale of the graph. The vertical scale is different from horizontal scale. You know? The vertical scale is 1 centimeter to 1, but horizontal scale is 2 centimeters to 1. So we have to be careful. All right. So on this line, this unit on the horizontal scale, that is 1. But on the vertical scale, this is 1. So on the horizontal scale, 2 lines is 1, but on the vertical scale, 1 line is 1. So you have to be careful with these things. Don't just start work. You have to look what you're doing. Always check the scale of a graph before you work on it. That's what I told you. All right. So you pass through this point, negative 2. Then the gradient, we're drawing the G. We're drawing G of x equals x minus 2. So it means that the gradient is 1 over 1. Gradient is 1, which is same as 1 over 1. Or it is 2 over 2. Or it is 3 over 3. You can use any one of those. So starting from here, you're going to rise 1, run 1. Or rise 2, run 2. Or rise 3, run 3. Let's say we use 2. Let's say we're using the 2 over 2. Right? You can use the 1 or the 2 or whatever. The 2 is convenient because we are at negative 2. That's why the 2 is convenient. Because we're at negative 2. So we're going to use rise 2, run 2 from this point. We're doing it the easy way. So rise 2 units and run 2 units from this point. So when you rise 2 units, you come to here. And then when you run 2 units, you come to here. So therefore, this is a point on the line. As easy as that. Right? That's a point on the line, you know. Rise 2, run 2. Nobody can say that? So this is a point on the line. Now we can rise 2, run 2 again. Rise 2 to here. And then run 2 more. When you run 2 more, you come over to 4. From 2, you run 2, you come over to 4. So that's a point on the line as well. And then you can rise 2 again. Rise 2, you come up to 4 here. And then you run 2. When you run 2 more, you come over to 6. 4 to 6. So that's a point on the line again. So all those points are on the line, just using rise and run. Right? If you wanted, you could have plotted some coordinates as well down here. You know that one coordinate will be 0, negative 2 because of the y-axis intercept. So one coordinate will be 0, negative 2. And you can put in another coordinate of x equals 2, for example. So when x equals 2, for example, put a 2 here, you get 2 minus 2 is 0. 2 minus 2 is 0. So you pass through those 2 points, right? And you can put in another one. So when x equals 4, for example, just to show you, I could put another one where x equals 4. So when x equals 4, you put 4 here. So 4 minus 2 is 2. So you pass through those points. So if you want to waste time, you could do that. I think the easiest way is what I just did. You put on the y-axis intercept, rise 2, run 2. And you draw those lines. So just draw a straight line through here now. Let's draw a straight line through here now. All right. Let's go. See if I can draw it. So draw a straight line. Oh Lord. That's it. So this is the line g of x. Remember this one was a function. Let's see. All right, this one was f of x. The curve is f of x. The curve is f of x. All right, and clearly now you can see that they intersect here and they intersect here. So those are the 2 points of intersection. All right. All right. So let's see what else I want us to do now. And I think they want some fun graph. So let's look at the question of this side. The next part now says, we draw the graph. Next part now says, hence, solve the equation, this equation. So, we're solving this equation right here. That's the next part. Solving this equation, that is really where g of x, no, f of x equals g of x. So that's basically where they intersect. So this is where they intersect right here, this point. So that point. So the answer for that is at the intersecting points. Those 2 points. All right, so the intersection, they intersect at x equals 2. So you can say that implies x equals 2, and also at x equals 5. Because you only can get x values from this equation because there are only x values in there. So you don't put no y values for the intersection. The answers are those x values. If you're solving an equation with x values alone, as what this is, your answer is going to be x values alone. So don't put the coordinates at the points. You're only finding the x values at the points where they meet. Don't put the y values. All right? You're solving an equation with x values only. But the equation that you're solving refer to the point where they intersect. That's a point of intersection. So this is where the points of intersection. Points of intersection. Points of intersection on the graph. So I only put in the x values only. All right. X values. That's what that equation means, because it's an equation with x values only. All right. But if you solve it the normal way, but you see the question said hence, you know. So because the question said hence, you can go now and say, boy, you solve this equation using a quadratic formula and all of that, or solve it by factorizing. They don't want that. The question only said hence. So it means that you wanted to do it from the graph, right? So on the graph, I would do something like, and put even on the graph, I would make sure to show them that I use the graph. I would go something like this on the graph and say, this is where f of x equals g of x. And I'm leaving this mark on my paper. You know? So this mark that I put on the paper up here, so f of x equals g of x, I'm leaving that on the paper. The examiner see. And then right here as well, f of x equals g of x. But the question says hence, I mean the more I use the graph to do it. So those are the points where x equals 2 and x equals 5. And the answer, you don't put the y values for your answer. All right? So basically that is that. Everybody good?
Yes, sir.
All right, so let's go. Next part. So down here, we say our answer is where f of x, let's put it back down here, is where f of x equals g of x. Well, it's already is up there. And so x equals 2 and x equals 5. And this is on the graph. On the graph. All right, so in what is at the top there, you have it, everybody can see it. All right, so that is question 9. All right, so come up now to question 10. Let's go up to question 10 here as well. Question 10. All right, so let's see what them say now. So for this question, they said it's a clear a circle to your question. So the diagram below not drawn to scale shows a circle center O. So if this is center O right here, that means that this line is a diameter. All right. So diameter rule might come into play. What are the rules again? Center rule, angle at center is twice angle at circumference. Diameter rule, angle subtended by diameter is 90 degrees. Same segment rule, angles in the same segment subtended by the same angle or the same arc are equal. Tangent and radius rule, angle between a tangent and a radius is 90 degrees at the point of tangency. Two tangents rule, only two tangents can be drawn from a single external point. Two tangents are equal in length, and the two tangents together with the two radii in the circle forms a cyclic quadrilateral because the angle between the tangent and the radius is 90. So the angle at the center between the two radii and the angle between the two tangents outside the circle, they add up to 180 degrees. They are supplementary. Then we come to which one now? The tangent cyclic quadrilateral rule. The cyclic quadrilateral rule says opposite angles in a cyclic quadrilateral are supplementary. So if you have a quadrilateral where the opposite angles add up to 180 degrees, then it is a cyclic quadrilateral. If you have a quadrilateral with the opposite angles add up to 180 degrees, then it is a cyclic quadrilateral. Also, if you have a quadrilateral in a circle with the 4 vertices of the quadrilateral on the circumference of the circle, then that quadrilateral is a cyclic quadrilateral and the opposite angles are supplementary. And then now we have the tangent and chord rule. The angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of a circle. The angle between the tangent and a chord equal to the angle subtended by the chord in the alternate segment of a circle. So those are the 7 basic rules that we have to remember, along with the other things like total angles in a triangle is 180, total angle straight line is 180 degrees, Z angles are equal, alternate angles are equal, U angles are supplementary. An isosceles triangle, 2 base angles are equal. A sector triangle is an isosceles triangle. These things also, you have to remember all those things, all right? So this question now apply all of those. It says the vertices H, J, K, and L of the quadrilateral lie on a circumference. It means that this is a cyclic quadrilateral right here. 4 vertices on the circumference. The opposite angles are supplementary in the quadrilateral. Then it says now PKM is a tangent. So this is a tangent right here. It touches at this point only. So it's a tangent. So some tangent and radius, tangent and chord will come into play. All right. And K is at the point of contact K. And then the measure of angle HJL is 20 degrees. We can see that. And the angle JKH is 50. And we can see that as well. JKH. Everything that they have said is in the diagram. All right. Question says, calculate given reasons the measure of angle HKL. Angle HKL. That's this angle down here. The one angle HKL. That angle. All right. What can we do? This angle is subtended by this chord right here that we want. The same chord is subtending this angle up here, which is 20. So it means that this angle equals 20. That's the same segment rule. But you can see that? Same segment rule. All right. And those 2 angles are subtended by the same chord. So we can write angle HKL is equal to angle HJL, angle HJL, which is 20 degrees. And the reason is the same segment rule. All right, it's here, angles in the same segment subtended by the same chord. The chord we're talking about is HL. HL is a chord right here. The same chord. Man, subtended by the same chord. HL. HL is a chord. Are equal. Those 2 angles are equal. That is the reason. So the angle that we want up here is 20 degrees. So let's put it on the diagram. So this angle is 20 degrees. 20 degrees. All right, so it's the first part. Let's put it up here as well. So this angle is 20 degrees right here. All right, so next part wants us to find angle JOK. It's the angle at center. So they want this angle now, JOK, this one. Now, this is an isosceles triangle. Why is it an isosceles triangle? Because this line and this line are radii. So, because those two radii are equal, it means that this angle over here is also 50. So this one is 180 minus 50 and 50. Because that triangle is an isosceles triangle. A sector triangle is an isosceles triangle. All right, that's what we're going to see for this one. So angle JOK is equal to 180 degrees minus 2 times 50 degrees, which is equal to 80 degrees. The reason is that triangle JOK is isosceles. So it's spelled with a S. Isosceles. So it's spelled isosceles. It's isosceles with angle KJO equals angle JKO, which is 50 degrees. And we also know that total angle in triangle JOK is 180 degrees. That's the reason. The total angle is 180 degrees and the angle up here is 50. So let's put it out. So this angle up here is 50. That's what was said. And the total angle is 180. So this angle is 80. Okay, the total angle is 180. Alright, so that's so far so good. Next part. Next part wants angle. We're going to use a tangent and the radius, or tangent and coordinate, so you can look out for it. And when you use a cyclic quadrilateral either. So look to use them. They must give you a tangent for a reason. And a cyclic quadrilateral. Next one I want is JHK. Angle JHK. That's this angle up here, what I want. JHK. This angle right here. Alright, so that angle now. Alright, go can get that angle now. Show you can get the angle there. Alright, use a different color. Show you. The angle is actually 40 degrees. Alright, that angle is 40 degrees. Let me show you why it is 40 degrees. Well, two reasons why it is 40 degrees. Alright, let me show you. There are multiple ways we can show why it is 40 degrees. Let's use this method. Let's use a tangent. And show it. Using the orange. Alright. So watch this now. So this angle, this triangle, let's use a tangent and chord. Let me see the marks further down. The marks anything else. Let's go first. No, the marks anything else. So we can use a method there. Alright, let's use that method. There are multiple ways we can show it, but let's use this method. So this angle over here that I want is equal to this angle out here, because this is the angle between this tangent and and the chord. And they say this chord is subtending this angle up here at the circumference. So the tangent and chord rule says that those two angles that I have marked are equal. What angle between the tangent here and the chord is equal to the angle subtended by this chord, which is the angle up here. All right, I don't want. But the question is now, what is this angle out here now equal to? This angle is equal to 40 degrees. Why? Because the angle between this tangent here now and the radius is 90 degrees. Right? And this piece right here is already 50. So to complete the 90 inside here, so must be 40 degrees. Hope everybody understand that. If you don't understand, you can let me know. So we can do everything of that thing and bring it back to where we were. All right. So trying to find this angle, which is now equal to this angle. And as I said, this angle is 40 degrees. And so this angle is also 40 degrees. So I'm going to do the explanation down here now. Firstly, let's go step by step. The angle outside here between the tangent and the chord. Angle JKP is equal to 90 degrees minus 50 degrees, which is 40 degrees. The reason for that is that the angle between the tangent KP and the radius KO is 90 degrees. A piece of it is already 50, so the rest of it must be 40. Then no, and then the angle that we want now, angle JHK is equal to the angle that we just found, which is JKP, which is 40 degrees that we just calculated. The reason for that is the tangent and chord rule now. That is because, so this right here is the reason for this part. And now we're doing the reason down here again now. Second reason for this part now. The reason down here is that angle between this means between tangent KP and the chord. Which chord? The chord KJ is equal to, or it equals the angle, that means angle, subtended by the chord. At H. That's the reason. Angle subtended by the chord at H on the circumference in the alternate segment of a circle. I guess if you write that, they'll give it the marks. That is sufficient. All right. So that is that. All right. Let's move down. All right. So the next part now. This part now is a trigonometry. It's not a right angle triangle, see there, so I know sine rule and cosine rule. And so the north lines, I know some bearings thing happening here now, right? Some bearings thing. Let's go. It says a ship travels from A on a bearing of 0, 30 degrees to B. So it's from here. It's from here to here. So this is the from position. Remember, bearing must always be measured at the from position. So from there to there is a bearing of 30 degrees. What does that mean? That means at this from position A, face north first, you have to turn 30 degrees to the right to face B. So it means that this angle in here is 30 degrees. 0, 30 degrees is that angle. All right, that's what it means. All right, got a bearing from A to B is 0, 30 degrees. And it is 90 kilometers away. And then now it travels to C, which is 310 kilometers due east. 310 kilometers due east of A. So this point is 310 kilometers due east. Due east simply means towards the east. Remember your cardinal directions. This is north, you spell V across the north line. V. So east is this direction. So this is 310 kilometers east. All right. So as we read the information, we're basically looking to see. All right. So that is 310 kilometers due east of A, means from A, as shown in the diagram below. It says, indicate on the diagram the 0, 30 degrees and the distance of 90 and 310. All right, so the 0, 30 degrees is going to be right here. This angle that is turned to the right, as I said, 0, 30 degrees is the angle to which you have to turn to the right at the from position to face up there. That is the 0, 30 degree angles. And the 90 kilometers was the distance that they told us right here. So this is the 90 kilometers up here. And then the 310 kilometers is down here. 310 kilometers. And so basically that's it, the information that they gave us. All right. Next part now says calculate the nearest kilometer, meaning that they don't put a decimal. The nearest kilometer is the nearest whole number. Calculate the nearest kilometer is a distance. Distance between B and C. So they're asking us now to find this distance between B and C. So this is pretty straightforward because since this is east, the angle between north and east is 90 degrees. I mean that this angle inside here so is 90 degrees. And if that angle inside here so is 90 degrees, all right, let's write it over. So this is 0, 30 degrees. This is 310 kilometers. And I'm saying the angle between north and east is 90 degrees. So this is 90 degrees. And so the angle inside the triangle here is 60 degrees inside the triangle. This angle inside the triangle is 60 degrees. That angle is 60 degrees. All right, and now they want us to find the length over here. So we have a triangle that is not a right angle triangle. So we cannot use so-called tower. We cannot use Pythagoras theorem. We have to use the sine rule or the cosine rule. And this one is a typical case for the cosine rule because we have two sides and an angle between them. When you have two sides and an angle between them, you can use the cosine rule to find the side that you want, right? It's a cosine rule. So let's write it. Cosine rule, cosine rule, cosine rule for the side BC. The cosine rule said the BC squared is equal to this side squared plus this side squared, which is the 90 squared plus 310 squared minus 2 times the 90 times 310 times the cosine of the angle between the 90 and 20, which we see is 60 degrees. I basically put everything in the calculator that you have here, and you get BC equals the square root of whatever everything there works out to. All right, so let's work that out. 90 squared plus 310 squared minus 2 times 90 times 310 times the cosine of 60 degrees. Cosine of 60 degrees actually a half equals, I'm getting 7,600 inside here. So and yes, square root that. Square root of the answer equals, and I'm set to the nearest kilometer. So BC therefore is 276 to the nearest kilometer. I get 276.22 to the nearest kilometer is 276 kilometers. And you put it on the diagram. This side is equal to 276 kilometers. As soon as you work out something, you put it on the diagram. All right. Then now, next part. So we put down where we have on this diagram. Inside here says 60 degrees. Let's put it up here. Inside here is 60 degrees. This is 90 kilometers. This is 310 kilometers. And this now is equal to 276 kilometers. We know the angle here is 0-30 degrees, right? So I'm not going to bother with that. 0-30 degrees. This is 90. So the angle here is 0-30 degrees, the bearing angle. So we don't have to put it. Or maybe let's put it 0-30 degrees. Let's zoom it up. I cannot zoom it further. Can I go more? Let's see. Yeah. So right here is 0-30 degrees. This angle right here. You have to turn to the right. All right. All right, so back down here now. So the next part is for us to find the measure of angle ABC. That's this angle we want here now. This angle. I'm looking at the diagram at the top. I want that angle, angle ABC. So this time we can use a sine rule because we have an angle and side opposite each other. And we know both of them. Once you have an angle and a side opposite each other in a triangle, we know both of them, you can use a sine rule. All right. I want to find the angle up there. So let's write it. Sine rule. Let's write it. Sine rule. Sine rule for, let's call it angle theta. Let's call it theta so we can reference it. Let's call it theta. Sine rule for theta. All right. We're going to call angle ABC. We're going to call it theta. I'm trying to say sine rule. So I'm going to say sine of the angle over the side opposite that angle is 310 equals sine of the angle that you know, which is 60 degrees, over the side opposite the 60 degrees is 276. Right? And then now, I multiply it with 310 up here. And so you get sine of theta equals 310 and the sine of 60 degrees divided by 276. You can work out that figure, but the theta is going to be sine to the minus 1 of whatever that thing in the bracket work out, or that thing there works out to be. And then you get
76.3.
how much? 76.3?
Yes, sir.
6.3 degrees. Alright, so let's put what that thing work out to do. 310 times the sine of 60, which is 0.866, equal that, and then divide by 276 equals 0.973, and then assign to the minus 1 of the answer Yes, I'm getting 76. 76.3. I'm getting 76.6 on my thing here. 76. Depends on how you
Sir,
correct.
that's what I got. 76.6.
Yeah. If I put 76.3, they give it a mark still, you know, but it's just when
But
you
it's to
correct.
the nearest degree.
Oh, that's at the nearest degree?
Yeah.
Oh, right. So if to the nearest degree, you have to put 76. No, well, based on the calculator, I have to put 77.
Yeah.
But I'm getting 76 point something, right? So let me correct that now. So I'm getting 76.58 degrees. To the nearest degree is 77 degrees to the nearest degree. All right, nearest degree. 77 degrees. So let's put it on the diagram up here. So this now is 77 degrees in case we need it. All right, so let's continue now. Next part now says determine, that's the last thing now. Ooh. Determine the bearing of C from B. The bearing of C from B. So this is the from position now, diagram at the top. This is the from position. All right, this is a different color for this last part. It's just the blue. All right, so the bearing from here to down here I want. All right, so what you have to do to get that bearing? At the from position, you have to face north first. Right, face north first. Face north first, and then you turn to the right until the first face the piece that you want. So basically, that is the angle that we want to have marked right there. We want that angle. All right, so we can find that angle. There are multiple ways you can find it. All right, multiple ways you can find that angle. But that is the bearing angle that I want. That's the first thing we have to establish. That is the angle that I want. And it can be worked out, right? Let me draw the diagram down here so we can see. All right, and work it out down here and show you. So down here, we have the north line. There. We have this line going down to C down here. We have this line here. The angle down here, so it's 30 degrees. All right, inside here is 77 degrees. All right, this is the north line. And we have this horizontal line. I really want to still. All right, so let's basically trying to show you how you can reason it out. The bearing that I want. When it says C, right, is A, and this point we don't want the bearing is B. All right, so this is a different color for the bearing down here as well. Let's use this color so I can show it. All right, so the bearing that I want is this angle that I want right here. So now this angle. Let's finish this. All right, the bearing that I want is that angle. Now watch this now. Because we know this angle is 30, right? Go back for the ink. I just want us to understand this part. Go back for this. All right, so this is an outline up here. All right, now this angle and this angle are what we call U angles. I'm going to double mark them, This angle and this angle are what we call U angles, or internal angles. They are supplementary. They add up to 180 degrees. So it means that this angle right here is 180 degrees minus 30. Because the two of them must add to 180, and so it is 150 degrees. This angle right here is 150 degrees. And then total angle around any point is 360 degrees. And so, if we go back to the color, which is this one. So this angle, oh, is not right. This one. Right, so we go back to this angle now then. Total angle around the point here is 360. Right? Total angle around the point in the middle here. Don't change, you know. Oh Lord. Touch around on this color, right? Total angle around this point here is 360. So this angle that we want, the bearing angle that we want, this is the bearing. This is the bearing of C from B, right? Just says B. That angle will become 360 degrees minus the 150 and minus the 77. Right? Because total angles around a point is 360. So it's 360. Write that better. 360 minus those two. So it's 360 minus 150 minus 77, which is 133 degrees. Alright, so balance on the calculation. That is bearing.
Yes, sir.
Right? So that is the answer. So you can write it down. Bearing.
Yes, sir.
Of C from B is 133 degrees, as shown in the diagram. You understand why these two angles are supplementary? It is U angle business, right? Internal angles.
Yes, sir.
All right, good. All right, good. So basically, that is that. So, yeah. So that is it. So everybody good?
Yes, sir.
Yes, sir.
Yes, sir.
Now shut it up.
Yeah, man, sir.
Yeah.
How the grades them look? Start scoring yourself and look at the improvements, and the question you get wrong, you work it over again. All right?
Yes, sir.
Yes, sir.
All right, so I'm going to send another paper soon. I'll keep working. Another multiple choice paper and some more paper too. So we'll keep it going. All right.
Yes, sir.
All right, guys.
Yes, sir.
Have a wonderful day. I'm gonna end it now.
Okay.
All right then.
Stay safe.
Yes, sir.
All right. Bye. Later.
Bye.
All right.